Question 10.2.3 wants us to prove that OS multiplied by MN is equal to WON multiplied by WS. So if we look at your solution sheet, you will see that there is 3 ways to do this. We'll go through the first 2. For the first 2, we will look at triangle OVN. Okay. And for the second triangle, let's change colors here. There we go. We will look at OWS. So we can see that between the 2 triangles, they have a common angle, and that's angle O2. Then we have proven in the past or previous questions that OVN and OWS are 90 degrees. Right, this was question 10.2.1 and 10.1, I believe. Those are 90 degrees. Then for the last one, we can say if that's true, that means that O and V must be equal to OSW. Reason being is that the sum of triangles, the sum of angles of the triangle. For this, it will be the same. It will be 180 minus this and that. And for that, it will be 180 minus this and that. And since those 2 angles are the same, it means that these 2 will also be the same. So it's the sum of in a triangle. Okay, so then we can say that these 2 triangles, which is OVN, is similar to the triangle OWS. If that's the case, we can say VN over WS is equals to ON over OS. So let's see those on the next sheet. So it's going to be VN, the side over the bottom side of the big triangle, WS. Then it's going to be our hypotenuse, which is ON, over the big side hypotenuse, which is OS. But we understand that VN is twice MN, right? Because they did say at the top there. So we understand VN is twice MN. We'll go ahead and substitute that fact into our equation. 2 MN WS is equals to ON OS, and if I multiply out everything, I will get that OS multiplied by MN is equals to 2 ON WS. So how do you choose the triangles you use? You always want to play to what they already have in the answer. So we can see here they're mentioning OS. It would be nice to have a triangle that has OS. They're mentioning ON again, would be nice to have a triangle with ON, WS, add that in. And with VN, you wouldn't have seen it, but as soon as you wrote it, you would ask yourself, how do I then get a relationship between VN and MN? Because that's the only side that was missing. Then you would remember that MN is twice that of VN, and you can use that explanation to get your answer. So yes, you always want to play and those triangles. The next method we're going to use OVN and OWS. Okay. So firstly, we'll say that OVN is equals to OWS. As you can remember, they were both 90 degrees from our previous question. Then in the previous question, we also showed that M1 is equals to S. It is an exterior angle to a quadrilateral. Then, because of that, we can then say that O1 must be equal to O2. This is the sum of angles in a triangle. So we can say that OVM is similar to OWS. This would allow us then to write the ratio OM over OS is equals to VM over WS. Now let's remember that VM is equals to Vn, and we know that Vn is half of Mn. So we're going to replace that. So we have 1 over 2 Mn is equals to OM over OS over WS. Okay. Then if we multiply out, we get Mn multiplied by OS is equals to 2 OM multiplied by WS. Now also let us remember that OM is equals to ON, as they are both the radius. So we can again substitute in and say OS ON and S. Now the next method says that if you want to use this big OWT, you need to first show them that WT is equals to WS before you use that big one. So you can use that big one with either that little triangle over there or that little triangle over there, but first show that this side is equals to that side.